We shall start. So let me just say a little bit about the final exam, which will be next week. Get here a little bit before 7 o'clock. We'll try to get started at 7 o'clock on time. Don't forget to bring your calculator and ID and a good pencil and eraser. And your note sheets or study guide, whatever you want to use. So the final exam will be 50 questions long. You will have 3 hours to complete everything, or just under 3 hours, just so I have 50 questions. Yep. And it's going to be all multiple choice. Okay. I know a lot of you guys complain about multiple choice. I do that just so I can get the grading done quickly and get your grades out to you as soon as possible. The way, if you know the process, like if you know the question, if you know the material, you should be just fine. I think what a lot of students complain about, and they'll say, I did so great on the quizzes, but I did terrible on like the midterm, or I did terrible on the final, or something. I think what happens is that on the quizzes, I give partial credit. So maybe you've gone through things, but you forgot a step, and so I won't take off all the points. I'll give you partial credit. On the final exam, the way it goes is if you forget a step, you're going to get the wrong answer. Okay, and I probably, in terms of the other answer choices that are available, one will probably be, if you forget to do this step, you'll get this answer. Okay, if you forget to do this step, you'll get this answer. If you do all the steps, you'll get this answer. Or, if you use the wrong numbers and do the steps, you'll get this other answer. So, the answer choices, so let's say, I'll talk about this as we go through the practice final. I'll show you, I'll tell you what the correct answer is, and then I'll say, these are possible wrong answer choices that you'll see. Okay? So, just be careful. A lot of you guys are asking, what should I study? And I strongly encourage that you study the practice final exam and just make sure your answers are totally 100% correct. And if that's the case, you should be okay. Yeah, Danielle?
So on the practice final, you give a lot of steps, and I know that you said it's not going to be the same on the other one. I'm just wondering, because you asked to find, what is the p-value? What is the test? So we know what the next step is.
Yeah.
Which ones are you going to take out?
It'll be similar. So in the practice final, each situation probably is followed by maybe 5 questions or so. Maybe on the final exam, there will be maybe 4 or 3 or something like that. Okay, so it'll be similar. Yeah, Cyrus.
Yeah, aside from focusing on the practice exam, shouldn't we also try and practice pacing ourselves? Say.
Oh, definitely. You should definitely pace yourself.
Yeah.
Okay?
Say if we just imagine that we're actually taking the legitimate final, so we just time ourselves and just go after
it. Try time yourself to do the practice final exam. You should be able to finish in under 3 hours. Okay, that's it's comparable in length. Okay, the final exam is 50 questions. You'll have 3 hours. Most students won't take 3 hours. Okay, but a couple will. Okay. Yeah. No, Josh. No questions. All right. You are allowed a sheet front and back. Okay. As we go through the practice final today, I'm going to be using the study guide, kind of pointing out, this is where you can see exactly where on the study guide you need to be and stuff like that. But we'll talk about that. Okay? Yeah.
Would we be able to use a printed sheet as a part of it?
Yes. You can do printed. You can write with pen after you've printed, and.
So we could use the study guide on the test.
Yeah, if you wanna, use the study guide, and then in the little open spaces, write tiny and red pen so you can see the difference and not get confused. You can do that too. All right. I've seen crazy note sheets. All right, but whatever works for you, that works for you. Okay. So yeah, I saw someone. I don't know how they read it, but then they shrunk 2 pages down onto one, and it's like you needed a microscope to read it. But whatever, they did that, and then on the back they wrote whatever they wanted to write. So you do whatever, okay? You get a front and back, and we'll go with that, okay? Okay. In my opinion, it's going to be very fair, but you just have to watch out for silly mistakes because the wrong answer choices will have silly mistake options. Okay.
Don't do it.
Okay. So don't. So just watch out. Okay. Is that good? We'll just power through this practice final exam, and if you guys have questions, ask away. This is your time. Next week I will not have office hours, okay? So no office hours next week before the final exam. So if you have questions about it, now's the time to ask. I learned the no office hours thing the hard way when I had office hours, and then it was like 40 students showed up. And
Yeah, but will you have office hours for the rest of the week?
I won't. You can post questions on the Facebook group, and I'll try to answer you. You guys can answer each other. I think most of your questions will be answered tonight, though. I hope. Okay. All right. So let's get started. Okay. Number 1. So these are. I'll explain a few situations, and I ask which condition is violated. Okay. And you'll have a section just like this. On the final exam, there's going to be a few things, and I'm going to just ask which condition is violated. Okay, so number 1, subject as studies performed, bright lights and headaches. 80 randomly selected subjects are exposed to bright lights. 20 complain they experience headaches. 90 have less bright lights, and 12 complain about headaches. Are any conditions violated?
No.
So number 1, the answer is D. No conditions violated. Alright.
Why is that?
Alright. Violated. So number 1 is independent or random. Okay, there. The 2 groups, they both say randomly selected subjects. So that one's met. Big population. Okay. There it says 80 subjects are exposed to bright lights and 90 subjects are exposed to less bright lights. And so those are both of the sample sizes. The population has to be at least 10 times the sample. So are there more than 800 people that can be exposed to bright lights, and are there more than 900 people that can be exposed to less bright lights?
It doesn't.
Yes. Okay. There's millions of people out there. Okay. So B is fine. C, large sample condition. Okay. Here you're supposed to check n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. Okay? Here I didn't give you a p, but you can kind of figure out your p hat. And actually, just look at those numbers. How many had headaches? 20 in one group, okay? That's bigger than 10. And if you do 80 minus 20, you get 60, and that's also bigger than 10. And then 12 had headaches, that's bigger than 10. And if you do 90 minus 12, that's 78, also bigger than 10. So if you're just getting counts, you can just you can see if that's bigger than 10 or not.
So this is the proportion.
Yeah, this is proportions because it's a categorical variable, right? Did you get a headache or no headache? Okay, there's no mean or standard deviation. It's a categorical variable. So it's proportions, and you're checking n times p. If it was a numeric variable, the large sample condition is the sample has to be bigger than 25. Right? Yeah.
So it doesn't put a percentage, you just take the number there for the sample?
Yeah, just take the number of successes, in that case, number of people with headaches. And then you also do number of failures, which is the sample size minus the
So
successes.
20 and 12.
20 and 12, and also 80 minus 20 and 90 minus 12.
So we're supposed to do n1 times p and n2 times p for both the samples.
Yes, if you have something like that. Okay, number 2, confidence interval for certain disease, 300 randomly selected subjects, 2% have the disease, any conditions violated, okay? Random is met, big population is met because we can have more than 3,000 people to study. Large sample condition is not met. 300 times 0.02 is 6. So 6 is less than 10. So 2, large sample condition. Number 3.
Just says violates the success and failure condition.
Yeah, I was confused about that.
Yeah.
What? Does it say success and failure?
Yeah, it says violates the success failure condition.
Oh, you know what? Success failure condition, same thing as large sample condition. So I apologize about that in the answer sheet. The answer sheet 2 should say large sample. Large sample condition. I'm sorry.
How dare you?
How dare I write the wrong thing? You know, that was because of a textbook change. And in textbook, the old textbook, the large sample condition was called the success failure condition. Okay, but it's the same concept. Number 3, a student has to conduct a survey for a school project, and he goes around, all right, 100 people, 45 say yes. What's that? Not random, okay? And number 4, company wants to survey its employees, 800 employees, it decides to select 100 of them and ask them questions. Okay, any conditions violated? Big population. Okay, company needs to have at least 1,000 employees if they want to sample 100 of them.
I don't get that though. Like I would think always a large population would be more accurate. I don't know why it has to be 10 times smaller.
You mean a larger sample?
Just in general, like I would think
Okay.
that having a larger sample is always.
Yeah,
gonna
you
be
know, a
better.
larger sample is better, except that you can't generalize if your sample's too large. Then at some point you just got to do a census. If you're going to do more than 10%, you got to do a census and ask everybody. Otherwise, you can't generalize. All right. So that's that for the
I have a question.
conditions check. Yeah.
So the second, what were they? Was it the mean or proportion?
Okay, so number 2 is it, are we dealing with means or proportions? Number 2, we're dealing with proportions because, do they have the disease, yes or no? That's proportions. Number 3 is also proportions because he's asking them a question and they answer yes or no. So that's going to be categorical, that's proportions. And number 4, it doesn't actually tell you what he's surveying. So that one could be either means or proportions.
Oh wait, so how was number 2C again?
Because if you do n times p, you get 6. N times p is 6.
Oh, when I did 300 times 0.2, I got a 60, unless I
Okay.
did that wrong.
2%, what is 2% as a decimal?
Oh, 0.20.
No?
I don't know.
0.02.
0.02.
0.02. Okay?
Oh.
Okay, so be careful. That's a common mistake. It's going to give you the wrong answer.
Okay.
Okay? So 0.02. 2% is 0.02. Alright, number 5. Okay, so it talks about number 5 through 10. It says, a farm wants to test 2 different diets for their cows to see which diet causes more weight gain. And they randomly select 10 cows to give diet 1, 12 cows for diet 2. After 2 weeks on diet 1, the 10 cows gained an average of 15.2 pounds with a standard deviation of 4.1. And then after 2 weeks on diet 2, the 12 cows gained an average of 12.6 pounds with a standard deviation of 3.4 pounds. the following questions refer to a 95% confidence interval for the difference in average weight gain. Okay? So here we are dealing with, how many samples do we have?
Two samples.
We've got 2 samples, and are we dealing with means or proportions? Means, okay?
Because there's a standard deviation.
Yeah, there's a standard deviation, and you see the word average. It's a numeric variable, okay? So you identified we've got 2 sample, and we're dealing with means, okay? So that's going to help us out in figuring out what to do next, okay? So then it says, you know, for problems about confidence intervals, you should be able to answer these questions. So I'm looking at the study guide here, okay? So part 1 says, what is, so number 5 says, what will be the center of the interval? What will be the center of the interval?
15.2 minus 12.6.
Yeah, so if you're not sure what yourself, you can look at the study guide, and it says, for 2 sample means, which is the situation we're dealing with, the center is the difference between sample means, which is x1 bar minus x2 bar. In this case, it's 15.2 minus 12.6, and we get a difference of 2.6. Okay, so this is the correct answer choice.
The difference between, what did you say?
The sample means.
Oh.
The sample means. Okay, and that's right there in the study guide. Confidence intervals. What's the center, and which situation are we in? 2 sample means. X1 bar minus x2 bar. Okay, so that's the right answer. Okay, wrong answers that might appear, okay, for this kind of problem. So other wrong answer choices would be where, no, I probably won't put negative 2.6, but I'll put something like 4.1 minus 3.4. Okay, that's taking the difference of standard deviations. Or also wrong would be 10 cows minus 2 cows, okay? Or 10 minus 12.
What if you subtract 12.6 minus 15.2?
If you did 12.6 minus 15.2, you'd get negative 2.6. Okay, so if I label these Diet 1 and Diet 2, or Group 1 and Group 2, do Group 1 minus Group 2. I probably, for the confidence interval, I probably won't put the negative version on there as the wrong answer choice, okay?
Yay.
But do it this way, okay?
You said on the study guide that
Yeah.
is, where is it on the study
x1 bar minus x2 bar, okay?
Number
It
5.
says,
Oh, yeah.
what's the center? That's the question, right?
Yeah. I see.
Alright, so the 2 samples are the means, right? Oh, because
This is the mean of sample 1, and this is the mean of sample 2.
it says right there, like, I mean, I thought that said 2 samples minus mean, so.
No. This is the situation that we're dealing with.
Okay.
Okay? 2 sample means, right? There's 4 that you have to deal with, and I talked about on the very beginning of the study guide. I say you can have 1 sample proportion, 2 sample proportions,
Right.
1 sample mean, 2 sample means. You've got to be able to read a problem and say, I am dealing with proportions or means. I got 1 sample or 2 samples. You've got to be able to say that. Otherwise, you'll be in big trouble.
And isn't it an easy way to differentiate whether it's a proportion or a means is a standard deviation?
Yeah, if you see standard deviations, definitely you're dealing with means, okay? But the key, you shouldn't just be looking for standard deviation, okay? You should say, is this a numeric variable or is it a categorical variable? Numeric means means, categorical means proportions. That's the key difference. And then,
That's on the study
do I
guide.
have 1 sample or 2 samples? That's the other part. Alright, number 6, what do we use for T star? So this is our critical value, okay? So for here, we have to figure out our degrees of freedom. So what is our degrees of freedom? N minus 1, okay? But I've got 2 different n's, so which n do I use?
Smaller one.
The smaller one, which is what?
10
10.
minus 1 is 9.
Okay, so my degrees of freedom is 10 cows minus 1. I've got 9 degrees of freedom. And what is my level of confidence here?
90%.
95%. So I go to the table and I look up 95% confidence with 9 degrees of freedom, and my value is 2.262. Okay, and again, that's explained right here in what is the critical value on the study guide. Okay, for degrees of freedom, the degrees of freedom for 2 samples is going to be n minus 1, and you look on the t table. What is the standard error? Okay. Yes.
Little thing, so when there are two n's, we just use the small one. For the
Yeah.
big-
So you had a 10. One n is 10, and the other n is 12.
Right,
Okay.
so we use the 10.
Yeah. So a wrong answer choice will be the t star for 11 degrees of freedom. Okay. If you use n is equal to 12 and you do df is equal to 12 minus 1, you're going to get 11 degrees of freedom, and the wrong answer choice will be the t for 11 degrees of freedom. Okay. And then probably other wrong answer choices will be the t for 90% confidence or 99% confidence. So be careful. Okay. These are the silly mistakes that will mess you up. Yeah. Joey.
Why isn't it 12 minus 1?
Why isn't it 12 minus 1? Okay, so the rule is
To use the small one.
you use n minus 1, and if you've got 2 different n's, use the smaller n. Okay, that's just the rule. Okay?
So we don't use 12, but 10.
No, you use 10 as your n, and you do 10 minus 1. Okay?
Oh yeah,
And if-
that's what I meant. That's what I meant.
Yeah. So again, if you look at the study guide, what is the critical value? And it says for 1 and 2 sample means, the t star comes from the t table, and the degrees of freedom is going to be n minus 1, and you use the n of the smaller sample. Okay? Do you guys have the study guide with you?
Yeah, thank you.
Okay? So it's all detailed right there. You just follow this, you'll be safe. Okay?
In the book, we have one question, and I think the number was 42, and you went with 39.
Okay.
Something like that.
So if
and we also had like
if
40.
whatever reason is okay, well, there's a problem in here. If you can't find your degrees of freedom in the table, always round down. So if whatever reason 9 wasn't listed but 7 is, and 9 and 8 weren't listed, just round down. Okay? Never round up. Never
Oh,
round
that's right. 39, don't go to 40, go to 35.
Always round down.
Always round down. If you can't find it in the table, always round down. If you can find it in the table, use that number. But if you can't find it in the table, always round down. Yes?
Yeah, but the question was 45, and we had 40, but you went with 39.
Oh, did I?
Yeah.
Okay, I probably screwed up. I probably messed up. Okay.
Where? Where'd you miss?
I don't know. So it's in one of the homework problems.
Yeah.
Okay.
Okay, so if we don't find 40, we go down to 39. huh?
39.
Okay. Always round down if you can't find your degrees of freedom. Okay. I'm gonna sound like a broken record because you guys asked the same questions. All right. What's the value of the standard error? Okay. So standard error again. For 2 sample means, the standard error, I give it to you right there in your study guide.
Square root
S1 squared over N1 plus S2 squared over N2. Take the square root, and you get this. So you do 4.1 squared over 10 plus 3.4 squared over 12. Take the square root, and you punch that into your calculator, and you get 1.626. All right. And that's that, okay? Alright, create a 95% confidence interval. So you put all of these things together, and you get 2.6 plus or minus 2.262 times 1.626. And when you do that, you get whatever it has, the answer sheet has.
Minus 1.078.
Minus 1.078 to
6.278.
6.278. Okay, this is the on the low end and on the high end. All right, and so again, number 8, you can put that together.
By the way, there's something where we just completely discard the negative sign. That's that, right?
When you're looking up the p-value, but we're not doing that here, okay? Okay, so number 9 says, based on this confidence interval, do you conclude that there's a difference in average weight gain?
No.
And the answer is no. Why?
The zero is.
Oh.
0 is in the interval, okay? So 0 is in the interval. So there's no evidence of a difference.
So that's always the case, right, if zero's in the interval,
Uh,
or no?
it's always the case when you have two samples.
Yeah.
If you have two samples, you're looking for 0. If it's only one sample, you're looking for whatever number
Whatever that number is.
they give you. Okay.
Wait, so just to make sure, the formula is the x plus and minus the critical value, which is t, and then multiplied by the standard error.
Yeah, except this thing is either your observed difference or whatever it is. Okay, so the center of the interval plus or minus t times the standard error.
So 0 is in the interval because there's a negative? Negative
Yes,
1 point.
yeah, 'cause it
If it
goes
wasn't
from-
negative, then it would just be like 1.
If it was positive 1 to 6.278, then there's no 0.
Right.
But there it goes from negative to positive.
Then for the one sample, you said you look for
It's in
Whatever,
the question.
it'll be in the
Whatever.
question. I'll say like, is there evidence that it's different from 15? You're gonna be looking for 15 in there, okay? And so, and again, that's also written in the study guide. It says for two sample means, the question might ask if there's evidence that the means are different. You'll see if 0's in the interval. Okay, it's written right there. So you guys, if you follow this, if you can follow directions and be able to think a little bit, you should all get 100%. But that doesn't happen.
And obviously if 0 is not in the interval,
Then you got evidence
Right.
of a difference.
Right.
Evidence of a difference. Okay. All right. If we made a 90% confidence interval, how would it compare to the 95% confidence interval?
90% interval is 1 hour.
Yeah. So we're gonna give up some confidence to create a more narrow or a tighter range. Okay. So 90% will be more narrow. Questions? This feeling good? All right.
I'm good right now.
Feeling good.
Tuesday.
I know. Okay, number 11. At the ruler and yardstick factory, a machine is suspected to be defective. The yardstick it produces are supposed to be exactly 3 feet long. You measure a random sample of yardsticks and find that the average is 3.02 feet. For shame. With a standard deviation of 0.03 feet. Is this evidence that the machine is producing yardsticks that are too long? Okay? So is this a one-sided or two-sided test? One-sided. How do we know it's a one-sided test?
Because it's greater than.
Well, how do we know it's greater than?
Because it says too long.
Because it says too long. Alright? The key word there is too long. If it said too short, it would also be one-sided. But if it asked the word, if it had the word, is it different from 3, then we would have a not equal to, or if it's, I don't know, something like that, okay?
So it's two-sided is two-tailed, something.
Two-sided would be a two-tailed test, yeah. Two-sided, two-tailed, those are all the same thing, yeah.
We don't do 1 minus at the end because we're dealing with means, not proportions. This is greater
Oh,
than. if it was
when we look it up in the P, when we look up in the T test, yeah.
Oh, we still do it from the T table. We're gonna subtract the P value from 1.
Oh, no, we don't do that. We don't do that because we're using the T table, yeah. So for means, we use the T table, we don't subtract from 1, yeah. Okay, is that right? So too long, we got a one-sided test. So number 12 says, what would your hypotheses be? Okay, and a lot of you guys got this wrong on the quiz. Okay, when I asked for the hypotheses, a lot of you guys put down the wrong things for the quiz, okay? So the correct answer, alright, are we dealing with means or proportions?
Means.
Means, oh yeah, I should put this at the beginning. we've got means, and we have one sample or two samples?
One.
One sample, okay, so we got one sample mean. Alright, and this is a hypothesis test, and so you can look on the other side of the study guide.
So you mean means always equal one sample?
I'm sorry?
Do you mean means always like involve one sample?
No, means will sometimes have two samples, okay? But, so there's four situations, right? You got means with one sample, means with two samples. This one is a situation where you got means and you have only one sample, okay? So the hypotheses for means of one sample, okay? It is written right here. It's got, the null is mu equals something, and the alternative is mu doesn't equal or greater than or something, okay? So in this case, because we're dealing with means, we're going to put in mu, and it should be equal to, what? 3. The yardstick should be equal to 3, and the alternative is what? Whereas
Mean
is
is
this
greater to
evidence that the yardsticks are too long, so we're doing mu is greater than 3, okay? Alright, so let's talk about wrong answer choices. Alright, so wrong would be, okay, so sometimes I saw this, H0 equals 3, this is not a null hypothesis, okay? You've got to put in a mu there, okay? So this is wrong, because there's no parameter there, there's no mu, okay? Also wrong would be to say P is equal to 3, okay? These are all wrong. Another one would be X bar equals whatever, 3.02. Anything that uses 3.02 or uses X bar, those are wrong, okay? This is the only one that's correct, but you see a lot of these things, okay? And then also anything with a not equal to sign in the alternative is also wrong. So, be careful, be careful.
Yeah, in the actual final, are we gonna be given more space in between questions to actually do the problems?
Yeah. Okay, there will be enough space for you to do the entire question. Kind of like the midterm exam, I felt like there was enough space for you to do all of your work on the exam itself.
Okay, good, because this is ridiculously small.
It's a practice final, okay? It's
But you're supposed
different.
to do the work like off
You're supposed
the
to do
paper.
the work on a separate paper.
Yeah.
Okay? And again, be careful, because the wrong answer choices will all look a little bit right, but they're wrong, okay? So you should be able to pick out the correct one, okay? Can you pick out the correct one? Is that alright? I'm not trying to be evil here, but I just want to make sure you got it down. Alright. What is the value of the test statistic? Okay? So in all of these cases, the values of the test statistic is, what we observe minus what's in the null divided by the standard error. And what did we observe this time? It's going to be 3.02 minus the null, which has a 3, divided by the standard error. Okay, so what is our standard error? Okay. Yeah, so we got to figure this out. So again, you can follow the study guide. And so it says for one sample mean, the standard error is S over the square root of n. So in this case, 0.03 divided by the square root of 40. And I get this tiny little number. 0.0047. Okay. 474. Okay, so try not to round too much. Try not to round too much. And actually, when I do this, I don't do any kind of rounding. So you're going to have, on top, you're going to have 3.02 minus 3 divided by 0.00474. If you keep the decimals going, it says 47434. Okay, and you get a z-score of 4.216. 4.216. So that's your test statistic. I'm sorry, not your z-score. Test statistic. And so to get our p-value, we have to go to our t-table and look up 4.216, okay? So how many degrees of freedom do we have in this problem? 39 degrees of freedom, okay? So our degrees of freedom is 40 minus 1, and we have 39 degrees of freedom, okay? But when we go to our t-table, we'll notice that we don't actually have 39 degrees of freedom, okay? So what do? We always round down, okay? And we use 35 degrees of freedom. Is that all right? Okay, and so I go into the row with 35 degrees of freedom, and the numbers that I see towards the end are 2.438 and 2.756. No, 35 degrees of freedom, 2.438, 2.725. And because we have a one-sided or one-tailed test, I'm going to copy the numbers from the one-tailed probabilities. I have 0.01 and 0.005. So where does 4.216 fit?
Past
past the chart.
Falls right here. So what is my p-value?
0.005
Yeah,
is
so
greater
my
than.
answer is less than 0.005. Okay? You got to know it's less than 0.005, okay? So wrong answer choice would be p-value is greater than 0.005.
Where are you finding 35 on the T2?
Yours says 30, right?
Okay.
Just use 30.
Oh, okay.
Just use 30 then, okay? Yeah, I passed out a t-table last week, okay? So it's a little bit different from what's in your book.
Okay.
This is the one that's going to be on the exam,
Cool.
but it's similar, but just a little bit different.
Okay.
So don't split it. Yeah, Danielle.
Did that remind you?
Can I get a copy of that?
You know what? I don't know if I have any.
Not now, I mean before.
Yeah,
I keep rounding my p-value, does it make a difference, or how many decimal places should we have?
so your p-value, just keep whatever's written in the table.
I shouldn't round, I mean, when I get into my calculator, when I get my test statistic, sorry, my test statistics, when I keep rounding.
Oh, okay. Yeah, you can round that. That's fine.
So it wouldn't matter if it was like 4.22.
That should be fine. So on the
You just know it's past points.
yeah,
0.05.
I mean in the answer choices for the test statistic, you know, I will have an answer choice, and maybe you'll see 4.216 as listed as an answer choice, and you're getting 4.22 on your calculator. Pick the closest one, okay? So if you don't see your exact test statistic as an answer choice, just pick the closest one. Okay, and this is our p-value, less than 0.005. Okay, is that all right?
So it's less than 0. Oh, I get it. Anyway, I'm good.
Yeah. So this is that's wrong.
I did that earlier and I got less than 0.1 or 1, not
0.01.
Yeah.
Okay. I think with this table you usually have less than 0.005. All right. So if our alpha is 0.05, alpha equals 0.05, what's our conclusion?
That we don't reject.
the null, right? So the p-value is less than alpha. So we reject the null. Okay. So this is the correct answer choice. You know, other answer choices, I'll put in p-value is less than alpha, so we don't reject the null. Okay, but that doesn't make any sense, right? Other wrong answer choices would be the p-value is greater than alpha, so we reject the null or something, you know? Okay, so think variations of this. So you gotta know what you're doing and this is the correct one. Yes?
What if, it's one of the ones where there's a, interval p-value?
Okay.
And there, you know, there's two
Greater
numbers
than
between,
the
and
accepted?
the alpha happens
Yes.
to be the same as the lowest number.
Cause if it's less than we reject it.
It
Okay,
happens
so,
over-
yeah, alright, we'll talk about that. Okay, let me demonstrate with an actual example, but let me, get, John,
Where did you get to use the 0.005?
So my p-value is where did I get the 0.005?
Yeah.
So do you have one of these t-tables?
Yeah. So we can do it.
Okay, so this one's a little bit different from the one in the book, okay?
Yeah, that was. Okay, anyways.
Okay, so I think when you use this one, you'll get 0.005,
For what number?
for the p-value, less than 0.005. Josh?
I don't know a question, that was really insulting.
No, I'm sorry, you are,
That was really insulting.
I'm sorry, you are, no, I got it. You are,
Come on.
Ariane, no.
Yeah, Ariane.
Ariane, sorry.
I mean, I would rather you call me Bob than
Bob, I'm sorry, my bad. Ariane. You, no question?
No.
Okay, my bad.
The questions haven't begun.
Okay, number 16?
You have a lot of
okay.
students too.
Alright, is this okay, number 15?
Yeah.
Okay, and number 16. Alright, if we made, so, we chose to reject the null hypothesis, so if it was a mistake to reject the null
It's
hypothesis,
an OJ.
that's a
Type 2.
type 1 error. If it's a mistake to reject the null, okay, is a mistake to reject the null hypothesis, that is a type 1 error. So if it's a mistake to reject the null hypothesis, that is a type 1 error.
Study guide is amazing.
Isn't it?
Yeah.
Got everything in it.
Yeah, I was gonna ask, but this is a good question.
So type 1 is rejecting the null when it's correct.
Yeah. Type 1 is rejecting the null when it's correct, okay? Also written at the very bottom of the study guide. If you made the wrong decision, what kind of error is that? And then it talks about it right there, okay? Alright, those of you guys who just came in here, I've got the answers to the practice final. So come up here and grab one page of each, okay? There's two pages you gotta grab. Alright. Any questions on this? Okay. You guys are all smiling and nodding along here, so I'm hoping that's okay.
Yes.
And I hope that means you guys will do good, do well next week. So, well, and also do good, right? Help people in need. And,
Let me just go back over where you got I understand the whole p-value thing, but just where, on your degrees of freedom, we have 39.
uh-huh.
We don't have 39 on the table, so we have 35.
Okay, yeah.
And you want a 95% confidence interval.
No, we're not making 95% confidence interval.
No?
We're looking for the p-value. It's a hypothesis
You're looking for a
test.
p-value, okay, right. So where did you get that?
So you're looking up, you're seeing where your test statistic fits in the lineup, in the line for the 35 degrees of freedom.
Okay.
Okay? So all the numbers are smaller than this. 4.216 is bigger than any of the numbers in there. And that means your p-value is going to be less than, yeah, there's 2 pages to grab each one.
Okay. I got it now. Thank you.
Okay. Alright, is that alright?
Yep.
Okay. Trina, we got answers to the practice final. Okay, right there. There's 2 pages. Grab one of each. Okay. And you can turn in your homework and pick up your graded stuff here. Let's see. Okay, number 17. Alright, so it says, researchers believe that 14% of the population is left-handed. A local school decides to see if their students have a different proportion of left-handed people. The school has a total of 1,500 students, and they randomly select 90 students for the study. They find that 15 of them are left-handed. Is this evidence that the proportion of left-handed students is different from the population proportion? Okay. Anyway, are we dealing with means or proportions? Proportions, okay, it seems pretty clear. We're talking about proportions there. And do we have one sample or do I have 2 samples?
One sample.
Alright, so proportion, 1 sample. Alright? Okay, and then number 17 just says, what's the sample proportion? What's the sample proportion? 15 divided by 90. So my p hat is 15 over 90, and that gives me 0.1667, alright? Or something like that.
The p hat of the.
Yeah.
I keep rounding, is it okay if at the end, the interval's a little off?
Yeah, that's fine. That's fine. I'm sure it'll be fine. Okay?
Aren't you better off just not rounding, right?
Yeah, it's better not rounding, but you know, at some point you're gonna have to do some rounding, right?
Yeah.
Alright. Okay, so wrong answers would be like 90 over 1500, or 1500 over 90, or 15 over 1500, or whatever, you know, 90 over 15. These are all bad numbers, okay? Don't do any of those.
It's supposed to be x over n.
Yeah, x over n. Okay. How many left-handed people? 15. How big was your sample? 90. Okay. 18. You want to make a 90% confidence interval. Okay, what critical value z star would you use? Okay. So if you forget, you can look at your study guide, and it says, what is the critical value? And it says for one sample proportion, which is the situation we're dealing with here, proportions one sample, alright, the critical values are 1.28 for 80%, 1.645 for 90%, 1.96. So what's the critical value we use? 1.645. So our critical value z star, 1.645. 19. When making a confidence interval, what is the standard error? Yeah, exactly, okay? And again, if you're not sure, you can look at the study guide, and it says, what is the standard error? For one sample proportion, the standard error is p hat times 1 minus p hat over n, square root. Okay. So be careful, the p hat here is 0.1667 times 1 minus that, divided by 90, and you take the square root, okay? So because the numbers are actually going to be very similar to one another, the answer choices will probably be left in this form, okay? And so this will be the correct answer choice. Okay, you might also see, okay, also correct, and would be if I wrote the fraction 15 over 90, yeah? Rather than 0.1667, and 1 minus 15 over 90 over 90, okay? These are both correct. Okay, but wrong, and these will probably be listed if this were a problem, would be what, 0.15 times 1 minus 0.15? over 90. This is not correct because it uses the proportion that's not from the sample. Yeah. Okay, so this one would be wrong, and there will be other numbers in there and stuff, but either of these are correct. And those would be your answer choices. Yeah.
So check to understand error, we shouldn't even get the answer. The
I
answers
mean-
are just gonna be the.
Okay,
like
yeah,
that.
you'll so you'll get the actual answers will be listed there also. Like, but I'll probably write 0.0393. Okay, this will be listed as an answer choice, but it will be in this form. Okay, just so there's no because if I crunch this out and I crunch this out, then people will complain, oh, one of them was 0.0393 and another one was 0.0392, and people will complain about that, okay?
Yeah, cause I got 0392.
Okay, well, yeah, so probably I'm gonna have it written like this, okay? So you can see that it's there, okay? But then you'll need the decimal to answer the next question, which is what's the confidence interval. You'll need to figure that out. But in terms of the answer choices, it'll be listed just like that.
So you're gonna write it in fractions, or you're gonna write in?
Well, that is to be seen, right? But fractions is a prerequisite for this class, alright?
Right.
So you gotta be okay with fractions as well. Alright? I can't Alright, what's the center? Alright, the center is p hat, okay? And again, if you're not sure, just check your study guide, and it says what's the center, and you say, oh, which situation am I with? One sample proportion, center is p hat, so 15 over 90, or 0.1667. And our 90% confidence interval, we're just putting everything together. 0.1667 plus or minus 1.645 times my standard error, which was 0.0393. And that's going to give me a range of 0.1021 to 0.2313. So when you do all the math here, okay? So I'm assuming you guys can use your calculators. Alright, based on your interval, is this evidence that the proportion at the school is different from the nation? So how do we answer this one?
Because you have to see if 14% is within the interval.
Yeah, you want to see, so the national percentage is 14%, okay? The nation is 0.14, and we ask, is 0.14 in the interval? And the answer is yes. So what does that mean?
It's not
If-
different.
Yeah, so the answer is 0.14 is in the interval. So we do not have evidence
Wait, where did you get?
Number 22 on the.
that the school's proportion
Oh, 0.14.
is different from the national proportion. Okay, so this is the correct answer. And what? Incorrect answer choices will be something like 0 is not in the interval, or something like that. 0 is not in the interval, so that means we have evidence of a difference, okay? That would be what you say if you had 2 samples, right? Or 2 means or something like that. But that's not the correct one, okay? Or I could say 0.14 is in the interval, so that means we have evidence of a difference, or something like that. Okay, those would also be wrong answer choices that you don't want to select. Okay, John?
So the 1500, this is gonna throw you off because you don't use it.
Yeah, we didn't use 1500 at all. Okay, so that's a number in there that shows up and had no use for the problem. Okay. Sometimes that happens, right? I'm not trying to be tricky, but that's,
Yeah,
there's just, sometimes in life we have more information than what we need, and we gotta, part of skill is, knowing what's relevant and what's not. Okay. More questions on this problem? These ones? Keep going?
Almost halfway there.
1, 2, 3.
Oh, so what are we gonna cover after we've gone over everything in the practice
What's that?
final? I mean, what are we gonna cover after we go over everything in the practice final?
I will just say I'm done, and then if you guys have more questions, I'll answer your questions.
Okay.
Okay?
I just
But-
wanted to make sure.
Yeah, I don't have anything planned after that, but
Hopefully we'll even have time to do anything else.
you know, we'll get through the whole thing. We're just
Yeah.
You made a
Because I have a feeling we might finish class early or something.
maybe, I don't know. I mean, don't, you know, those are famous last words, right? So, don't. Okay. So if I can do the entire test, talking through and explaining the whole thing within the time hour block, I think.
You get about 4 hours of question,
Crazy that you finish this test in
4 minutes of question.
Yeah. Okay. All right. So, 23. It says we buy a bag of Starburst candies and a bag of Jolly Rancher candies, and the bag of Starburst contains 80 pieces. 12 of them are cherry flavored. Jolly Ranchers have 70 pieces, and 14 of them are cherry flavored. Okay. Assuming these are truly random assortments, does this provide evidence that Starburst and Jolly Ranchers have a different proportion of random of cherry flavored candies? Okay, so group 1 will be the Starburst candies, and group 2 is the Jolly Rancher candies. All right. How many samples do we have, and are we dealing with proportions or means?
2 samples.
Okay. 2 sample proportions. Okay. So you guys are doing well here, but this is super important. All right. If you can't figure out whether you have proportions or means, and whether you're dealing with 1 sample or 2 samples, you will be in big trouble next week. Okay. So make sure you can figure this out. All right. So we are doing a hypothesis test. So what's the appropriate hypothesis?
No, P1.
Why did that one instead of, I know on the answer sheet it said you could do both, but why that one instead of the P1 minus P2 equals 0?
Oh, so I have either.
No, I know you have either, but because it's multiple choice, like why would you change them?
I
It doesn't
think-
matter if they're both the same thing, like you're saying?
Okay, so you'll see one. You'll see one of the correct. So there'll be 4 answers, right? 1 of them's correct, 3 are wrong. Okay, I'm not going to put both correct answers in there. Okay, so what you might see. So the answer choice either P1 equals P2 or P1 minus P2 equals 0, and the alternative P1 minus P2 not equal to 0. Okay, so wrong answer choices will have, you know, the greater than or the less than, okay? Okay, also wrong is if I put, in the null hypothesis, if I put P1 minus P2 not equal 0, this would be wrong, right? Because the
That's
null
always
hypothesis
equal.
always has an equal sign, but this one's wrong, so, okay? But these are common mistakes. So, on the quiz last week, a lot of you guys messed up the writing of the hypotheses, and I was very generous in terms of the partial credit I gave, okay? So, okay, or anything that uses mu or p hat, those are all wrong also. Yeah, Sarah.
The 0 way of writing it really confuses me. They're gonna have the other one also. I told you
No,
that
it's
last
just,
time.
it's just gonna
remember?
have one or
That's
the
really-
other, okay? don't get confused, okay? And it's also written right there, for two sample proportions, the null hypothesis is P1 minus P2 equals 0, and the alternative is P1 minus P2 not equals 0 or greater than or less than, okay?
But you know which one I'm talking about that I like.
I know what you're talking about, but
I like
Okay,
that
you
one.
that may or may
I
not,
agree.
that may or may not make an appearance, okay? You gotta be comfortable with both forms. Okay?
But it's, when
Like,
you think about it, it's
like if
obvious
you were
anyway.
taking a test on whether you speak Spanish or not, okay? And then part of, you gotta be able to, if somebody greets you with hola and you know, or they greet you with que tal or whatever, you know, you gotta be able to respond and recognize
say
that,
ni hao.
you know, that these are greetings and not, so you gotta be able to recognize multiple forms for the same thing. We got, whatever, okay.
Yeah.
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 For the,
It was pretty cool.
for this hypothesis test, what is the value of p hat? Okay, so p hat is the total number of successes over total observations. So we've got 12 cherries plus 14 Jolly Ranchers over 80 plus 70. We have a total of 150 pieces of candy.
Oh, I thought we had to divide 12 by the 80 and 14 by 70 individually first.
Yes, but that's for a different question, okay?
Oh.
But this is for the overall p hat, okay?
Oh.
What is p hat? We got to figure that out. And the answer here is 0.1733, okay?
So that's your pool.
Yeah, that's your, yeah, the other textbook called it p pool. This textbook doesn't. It's just called p hat, okay? So that's 24. Alright, and it says, what is the test statistic? Okay, so to get our test statistic, we got to figure out what we observed, what is the null, and what's the standard error. Okay, so all test statistics are observed minus null divided by standard error, okay? So the reason why I write it this way, according to our null, what's the difference that we should see? The difference that we should see is 0. But what did we observe? What we observed was P1 hat minus P2 hat. Okay, Cyrus, I think this is what you were talking about.
Yeah, I like that.
Okay. Oh, no, but I mean, this is going to appear always. So, this is 12 over 80 minus 14 over 70. And, I don't remember what this is. Huh? I kind of lost you?
Yeah, and actually what I meant was just finding the p hats for both groups individually, as in like you just do 12 divided by 80
Yeah,
first.
that's exactly what I'm doing right here. I'm doing that right here. Okay.
Oh no, I mean not find the t statistic. I mean like what you would do before you find like no, okay. I think I'm getting sidetracked there. Never mind.
Alright, no, I mean you gotta figure out p hat, and that's this value, okay? And the standard error, so again, if you check out the study guide, it breaks it down. It says, the test statistics always in the form observed minus null divided by standard error, okay? The observed value for two sample proportions is P1 hat minus P2 hat, okay? And that's this. And the standard error for two sample proportions is this crazy thing, right? P hat times 1 minus P hat times 1 over n1 plus 1 over n2. Okay, so you gotta figure this out. Okay, so this would be 0.1733 times 1 minus 0.1733 times 1 over 80 plus 1 over 70. Okay, so we put all of this together, and my test statistic is going to be 12 over 80 minus 14 over 70, okay, minus 0, over this, you know, whatever my standard error is, okay? So on the top, I get some number, you know,
Wait, so the observed, what you observed is 0.1733?
no, that is my p hat,
Then
but
what
that's
is
not
it?
my observed.
Then what is what you observed?
My observed is
Zero?
the difference between the two proportions. Okay, the difference between proportion of cherry candies
Okay,
and
and then
Starburst
so
and
it's-
cherry candies and
So
Jelly
it's that
Ranchers.
minus 0? Your null is 0?
My null is 0. So this is my observed. So my observed is 12/80, which is 0.15, minus 14/70, which is 0.20. So my observed difference is negative 0.05. That's my observed difference. Okay? My null difference is 0. So I'm getting negative 0.05 minus 0. That's what I have on top.
Okay, got
So,
it.
which is just negative 0.05 because the minus 0 doesn't do anything. And then on the bottom I have this, 0.1733. What's that?
619.0.061.
Mm-hmm.
Okay.
0.0619.
I believe you, but I'm just gonna do this. Zero 6,195, and then so I put that down on the bottom, and I get negative 0.05. I get negative 0.807. Okay, or that rounds off to negative 0.81.
Mr. Chen?
Yes.
I got 0.061905.
Okay, that's fine. No big difference.
No, you know what
Yeah, you got 0.619. Close enough. Close enough. Okay. It's not going to throw that answer off. Okay. You might get what? Negative 0.81. Negative 0.80. Okay. It's you're going to get something very, very similar.
Rounded to 3 or 4?
Now, whenever you get a z-score, you got to round off to 2 because the z-table only has 2 decimals
And
of
that's the
precision.
test
mean, generally
statistic
the-
is the
This is our
z-score?
test statistic.
I
Our
thought that was
test.
Z star was the test statistic.
That's your critical value.
Oh, yeah, no, right.
Okay, anything with a star is a critical value. This is a test statistic. It's a z-score, t-score. Okay. All right. This might be one of the hardest, and I want to make sure we're following it okay. All right. All right. And I guess the question is, I want to make sure you guys can follow what's written in the study guide and get to the right answer on your own. So are there any questions on why or who or what? I don't know the who question. Okay, so what's the p-value? What do we do for the p-value here? Okay, so I'm going to take this thing, negative 0.81, and I'm going to look this up in my z-table. So I got to look it up in the z-table. And I look up negative 0.81 and I get 0.2090. Okay, so look up in the z-table. And I get
And we do it times
0.2090, right? Okay, and so this is what we say, all right, for the p-value proportions you look for in the z-table and you find the area to the left, okay, which is what we've got. And then we multiply it by 2 because why?
two-tailed.
Two-tail test. I have a not equal sign in the alternative, so it's a two-tail test.
518.
So my p-value is equal to 2 times 0.2090, and I get 0.418. That's my p-value.
Where does it say that on the study guide? I know I got it.
Yeah, on the study guide it says, what is the p-value? It says for proportions,
Oh, I see, yeah.
if the alternative has a not equal side, find the area of one tail and multiply it by 2. Okay, that's what we did here. Okay, so what is the conclusion that I made? My p-value is greater than alpha, That part is correct.
So we do
Like-
not reject.
So we do not reject the null. Do not, okay? So be careful, right? If you say you do reject the null, that's wrong. So we do not reject the null hypothesis. Yeah, it's a lot. Sorry?
You're gonna ask it in the same format, more or less?
More or less, alright? I mean, the questions will be mixed around and different numbers, different stories, but more or less, very similar.
But you are gonna break it down. Like,
We'll
what
break
is
it down.
this? A, B, and C. What is this?
I'll break it, yeah, I'll break it down, you know. I'll say questions 8 through 12 are related to this.
Oh, okay.
Something like that, okay? So I added like about four questions for each scenario type of thing.
You're not gonna tell us the like hypothesis tests for
These
different
are all
students. Hypothesis tests for
proportion.
proportions. You're not gonna tell us that.
Huh?
You're not gonna tell us like that though, right? Like hypothesis tests for a difference in proportions kind of thing.
Do you perform a hypothesis test?
No, I mean you're not gonna like tell us exactly like what.
Yeah, I'm not gonna tell you exactly which
I-
one you're dealing with. You gotta figure
I thought
that
you
out.
just said that you were going to. I was like, what?
Yeah,
Okay.
Alright. Okay, so let's see 28, okay? So I thought this one was a little bit tougher, but we'll see, okay? Researchers wanted to know if drinking caffeinated drinks improve reaction time, okay? They randomly select volunteers in a blinded experiment, give some of them caffeinated drinks and others non-caffeinated drinks, and then they record reaction time. And it says group 1 had 30 people drink coffee, or have a drink with 300 milligrams of caffeine, and the reaction time was 580 milliseconds with a standard deviation of 110. Group 2 had 25 people drink containing 0 milligrams of caffeine. Average reaction time was 640 milliseconds with a standard deviation of 130 milliseconds. Is this evidence that caffeine improves reaction time? Okay. So when performing a one-sided hypothesis test, what should the hypotheses be? Okay, so we've got a null hypothesis and an alternative hypothesis. Alright, are we dealing with one sample or two sample, and are we dealing with means or proportions?
Means.
Two sample means. Okay, we can identify two samples, and we are clearly dealing with numeric variables, so it's means, okay? So what should the hypotheses be? So the null hypothesis, let's start off with that one. It should be what?
Mu1
minus mu2 equals
0.
0. Okay, mu1 is the group with people who drank caffeine. What does it mean to improve your reaction time?
Have a less number of times.
Okay, that means the time it takes you to react will be less, right? It means you've gotten faster. You've gotten faster, so that means it takes you less time to react. So improves means reaction time has decreased. Okay. So if group 1 is the one with caffeine and group 2 is the one without caffeine, mu1 minus mu2, should that be, this should be less than 0. Okay? Because your reaction time, so group 1 is the group that had caffeine, right? So will they have better or slower reaction times than the group without caffeine? Better. So are better reaction times longer or shorter? They're shorter. So this will have the shorter reaction time minus the longer reaction time. That would give us a what? Positive or negative number?
Negative.
Negative number. Okay? Because these are basically the reaction times of the fast people. These are the reaction times of the slow people. So if I do the fast people time minus the slow people time, that should be negative. If That's what we're looking for.
Can we not have one of these on the top?
Yeah, I second that.
Okay, so, yeah, I mean, this is a tougher question. There might be one of these types of things where you gotta read and you gotta think, alright? You gotta, it just requires some thinking,
God
just
forbid.
requires some thinking, yeah, I know. Can you imagine that? Now you gotta think. Alright, so what was the observed difference that we actually got? What's our observed difference? Yeah, okay, so our observed difference is group 1, mean of group 1, minus the mean of group 2. So 580 milliseconds minus 640 milliseconds. This gives me a difference of negative 60 milliseconds, alright?
That would be like x1, x bar 1.
Yeah, x bar 1 minus x bar 2, exactly.